I am Sonia Jennifer Ryan from the Department of Information Technology, JPR Institute of Technology. So today I am planning to take Unit 1. First one is going to be about object-oriented analysis and design. Can you hear me?
Yes, ma'am.
Can you please mute your call? Students, please mute your call. Okay. Object-oriented analysis and design. Generally, in any approach, there are any software architecture. The basic steps include we have something called as our analysis phase. Following our analysis is going to be in analysis we do the requirements gathering. Okay, that we come back. We have our analysis phase, then we design it, and then what do? We do the coding part, and then we do the testing phase. Okay, these are the basic 4 steps of our software development life cycle, or we call it as our SDLC, software development life cycle. Okay, but analysis phase. In analysis phase, what do? We gather the requirements. What requirements we gather? We gather the requirements of the user, as in what does he want, what does the software has to do. Next is going to be the design phase. In design phase, the main thing what we are going to do is we are going to check for the feasibility. Feasibility check is the main task here. And then what do? We draw the outline. We draw the outline of the requirement. A sketch or a blueprint of what do I need. And next, coding phase. This is where I do my actual implementation. Okay, and then following this is going to be the testing. I test for the I already told you in previous classes. Software quality assurance means when I'm testing, what do I test? I test if the user's requirements are being met. So I test for my requirements. These are the main 4 phases. So analysis, design, coding, and testing. Okay. So one more thing. In case of coding, this is where is actual implementation. And it's something called as forward engineering and reverse engineering. In forward engineering, what I do is I generate my code from my diagram. In case of reverse engineering, I generate my diagram from my code. And then keeping this in mind, we move further with the SDLC. So as I told you, object-oriented analysis and design means a software engineering approach where we create a group of interacting objects. Analysis, as I said, we understand the problem, we describe concepts, that is, we identify the requirements. Next is our designing phase. We understand or define the software solution that will be implemented in a code. Next, what is my OOAD do then? My OOAD will help me to emphasize on the logical solution based on my object. I give more importance to my object. And next, what is my development activities? As I already told you, analysis, modeling, design, implementation, testing, and my maintenance phase. So generally, there are 2 main views of a software: a traditional approach and an object-oriented approach. In case of my traditional approach, what will I have? I will just have a collection of programs or functions, and then what else will I have? As algorithms, the data structures is going to be my program. For that, what are the different models that are available? I either have my waterfall model, spiral model, or my incremental model. These are my traditional approaches. Following which I have my object-oriented development. So when I say here in traditional approach, it's going to be just a collection of functions. Whereas in my OOAD system, in the object-oriented system, I have both data with functions, not only functions. So in traditional approach, it focuses on something. So the same thing when I say object-oriented system, what will focus on data and objects. When I say objects, automatically will have my classes and my modules. So moving from one phase to another phase is going to be complex because I'm not taking data into consideration. Whereas here, moving from one phase to another is going to be easy. Because it is going to be easy, what will I have? Time become, it reduces the time. So it reduces redundancy. So if here reduces the time, what here I will have, it increases the time, increases complexity. So which one is a better approach of the oriented system development? Okay, so just a quick overview. Object-oriented system I am going to have, it's going to be a combination of my data as well as functionality. It focuses most on my data, gives more importance on the object classes, reduce time, reduce complexity. Moving from one phase to another phase is going to be easy. And next comes my object-oriented approach. Let's see this detail. As we already saw, it is going to give more importance to my data functions. Okay. Now, what is a software? Software is the discrete collection of objects that encapsulates their data as well as the functionality. Something like our encapsulation. And what will each object have? Each object is going to have a set of attributes as well as it's going to have a set of methods. For example, if I take car to be my object, what and all will be the attributes of my car? I will have what are things that describe the car? I will have my color, engine, model number. And what will be the functionalities? What are the works that I can do with a car? Open a car or close a car. Next, what will be the software by building self-contained modules? Okay, so each module is independent of each other, and these objects finally we group it into a class and which are responsible for its own being. So what are the benefits? The benefits are going to be faster development, reusability, increased quality, modeling the real world, and provides us with a stronger equivalence. Okay, the application is implemented in terms as how they are being described. Now, why do we go for object orientation? Because changing requirements is easy, easier to maintain, more robust, promotes greater design, code reuse. So in today's session, we mainly focus on what was our steps in software development cycle, what are our steps: analysis, design, coding as well as testing, and then we focus mainly on the two approaches that are being there. The traditional approach, we have two approaches. First one is going to be the traditional approach. I have my traditional approach followed by my object-oriented approach. And then what do we saw? The traditional approach focuses only on it just has my function. Here it has my data and function. So which means better performance, reduces redundancy, reduces the time. Here the performance is being reduced, it takes more time, increases the complexity. And then we saw why do we need an object-oriented approach, for the reason, what are the advantages. I will share these